Hello, everyone, and welcome to the Greater Central Florida Multifamily Investors Group meeting where we focus on investing where it makes sense. I'm your host, Ismail Ray Reyes, and this is for folks that are interested in growing their wealth through real estate investing. Whether you're a beginner or an experienced investor, hopefully you'll learn something valuable here tonight that will help you start and or grow your real estate portfolio and help you create that generational wealth. Joining us today is Justin D Angelo. Justin, how are you, man?
Doing good. I'm happy to be here.
Awesome, awesome. And Justin is the founder and CEO of Printera, a South Florida company specializing in 3D printed concrete architectural and landscape features. Ooh, that's a mouthful. You'll see that there's a lot to it, and I'm excited about what he brings to this group and the information that he's providing and the greatness of his company at this point. He founded Printera in 2021 and previously worked as an agile project manager for companies like Royal Caribbean and HSBC. Justin's got a business management degree from Bentley University and international experience living abroad. I like that. I love traveling. We need to chat about that a little bit when we get a chance. He's a husband, a father of two young children, and enjoys traveling and go figure home renovation. So really, really good to have you on here. And he and I, Justin and I have been discussing for the group here. We've been discussing for the last 2 or 3 months now how we can partner with a developer or a general contractor to develop a community of smaller footprint homes. And today we hope to present, mostly him, hope to present you with some of those ideas of how we can take this concept of tiny or smaller footprint homes and add another layer of what we call environmentally friendly construction, or in this case, carbon positive, homes that, while they're small, they are very resilient to, of course, for those of us here in Florida, to what Florida has to offer as it relates to inclement weather. So we're looking at that, and obviously, the idea that you can build something that has a carbon positive footprint is tremendous. I mean, I know that that's something that is attractive to me when we look at what's going on in the world and what's going on in many places. I mean, heck, South Florida the other day was underwater, right? I mean, I don't think there's any disputing that we have some environmental issues that we need to deal with. It's not the end of the world, but these are the kind of things that we're hoping that this technology and others can help us here in Florida, because as you're going to see here in the business case that I'm going to present to you, population growth in Florida is not slowing down. So these groundbreaking tiny houses, small footprint houses, use cutting edge 3D concrete printing for faster construction, reduced waste, and unique designs. But as I mentioned, what sets them apart is their carbon positive footprint. They actively remove more CO2 than they emit throughout their life cycle. And that's tremendous, especially as we look at, from an investor standpoint, things that can be attractive to, to governments, whether they're city or county and others, as we're looking to put some projects together. That's exciting for them. I mean, that is tremendous to be able to do the two things together there. So this is the future of affordable, environmentally friendly housing in Florida. Get ready to witness a game changer for sustainable living. And as I mentioned, before I turn it over to Justin, I want to take a couple of minutes to make the business case for tiny and smaller footprint homes. Justin's going to focus on the technology and he's going to focus on the actual engineering aspects. But I wanted to kind of add, since we have a crowd of passive investors here and active investors, and hopefully some general contractors, as I mentioned, and some developers, I wanted to talk about why it makes sense to do this. Florida's population is surging. We have an aging demographic and more single-person households that are driving demand for affordable, smaller homes under 1,000 square foot. Using this 3D concrete printing, we can reduce the costs, timelines, offer design flexibility, minimize waste, and align with sustainability goals for energy efficient, low maintenance units. Florida's projected population growth from 21.5 million in 2020 to over 26 million by 2040. The aging population, and aging, I mean folks over 65, is increasing from 2020, 4.5 million to 6.5 million projected in 2040. Folks seeking smaller, low maintenance homes. In addition, the rise in the number of single person households continues. And this isn't just Florida. We have, as families have gotten smaller, we have folks that really just want to live by themselves and they can do it, they can afford it. Obviously, they don't need a 3,000 square foot mansion, 5,000 square foot mansion, but they want to have their own piece of paradise, especially here in Florida. So, what this results is a 28.6% household growth in Florida from 2020 to 2040, almost 3 times the national average. And you align this with the growing demand for smaller, affordable units. Developing these 3D printed carbon positive homes could appeal to buyers seeking affordable, sustainable living in densifying urban areas, which we have a lot of them here, with high housing costs, and presenting potential real estate investors like myself and others with an attractive investment opportunity that we feel good about doing. So I think we can go into it much longer as far as why it makes sense. I think most people get it. The question is, how can we do it? And there's challenges, right? We have to work through, and hopefully we'll talk a little bit about the challenges as it relates to zoning and the size of the square footage, the size of the lots that we have to work with, these sort of things that, that I think if we can crack these issues are going to be a game changer. So without further ado, Justin, I'm going to turn it over to you, man.
Awesome. Thanks again, Ray, for putting this together and having me on to this podcast tonight. I think I think you did a nice job setting the stage in terms of where we're at and what we're looking to achieve. I just want to also add that beyond the specific technology set that I'm offering at Printera, I also firmly believe that a rising tide lifts all ships in this industry. It's such a new technology, and the country is vast, right? With over a 20 million home deficit. I think depending on where you're listening in, it may not be that you're in the South Florida market for one of these structures, but there are a lot of companies nationally that are working on their own implementation of 3D printing. And we do it a little bit differently, which I'll get into in the slides, but I just want to throw it out there that if you're not in our area, you should still look into it as an interesting means of construction for whatever kind of construction or commercial related projects that you might have. So just with that, I'll jump into the slides that I've prepared, and just kind of giving an overview of both my company and the technology that we're employing to focus on these tiny houses, as well as various other applications. So let's see if I have permission to share. There we go, screen share. All right. And Ray, since you're on, can you just confirm that you're able to see my screen?
Yep, I can see it popping in now. Yep.
Perfect. All right, so as Ray mentioned, we're Printera, so concrete 3D printing is what we're all about. And very simple, our mission is just to rethink, design, and automate the construction process, right, wherever possible. And at the moment, that's leveraging concrete 3D printing. As he mentioned, we're also located here in South Florida, so we're serving the entire Florida market. Projects, at least in housing, we're willing to go just about anywhere in Florida. And then, as you'll see in later slides, for projects that are outside of housing, we serve clients nationally. So there's a lot of different interesting elements. Even in this image, you can see an EV charging station as just one example of something that we can fabricate with concrete printing. A little bit about ourselves and kind of the background. So we're in a very early, new, blooming industry. And so with that said, even though we've only been around for about 3 years at this point, we're able to pretty much call ourselves veterans of this industry, just because of how new it is and how few players are currently operating in the space. So over the course of that time, in combination with Centerforms, which is a company that I acquired last year, we have a couple interesting kind of accolades. So we did print the first permitted residential project in Florida, up in Tallahassee. I have a whole slide dedicated to that, and we'll explain a little bit more. We engaged with a pilot with the U.S. Pilot project with the U.S. Air Force at Tyndall Air Force Base. We participated in the world's largest 3D construction printed building, which presently sits in Wellington, Florida. We'll see how long they hold that title because there's some other stuff happening globally. So it's something cool to keep our eye on. And then going beyond residential, there's other things that I didn't include here, but we did deploy the first artificial reef in Florida. We were able to do some commercial projects. So there's the Florida's first 3D printed bar in Tampa that we produced. A couple other interesting elements as we go, but that's just a little bit about our background. And what we're doing that's different from others is we're calling it pre-printed 3D concrete printing, which essentially means that all the items that you see in this image, as well as housing modules, we produce in a controlled facility in one location here in South Florida in Stewart. And where that's important is we're not lugging a ginormous piece of equipment to a construction site and contending with all types of weather conditions and site-related, hazards and delays. When you get your 5 o'clock rain shower in Florida, that's pretty typical. We're immune to that hurting us too much in case, unless of course the power goes out or something. But nevertheless, we have a little bit more longevity in our print cycles because of being in that controlled environment. So I'll get into the pros and cons of that a little bit more in the next couple slides, but that's the real key differentiator. So I like to start at a high level because a lot of people are still learning about what is concrete 3D printing, right? How does it work? And at a fundamental level, it works the same whether you're using the system like mine or a system that they erect on a construction site. And essentially what you're doing is you're inserting a dry material mix, right? In our case, it's a dry concrete. It's being dosed with a fairly accurate potion of water till you get a pumpable slurry. The pumpable slurry is pumped through a hose over to a robotic extruder, and the robotic extruder lays down the concrete one layer at a time until you have an object. And that object could be demonstrated here as just something as simple as a planter or an entire wall segment for a house, right? It all just depends on the scale of the machine and the capability of the material that you're printing with. One of the things that we really pride ourselves on at Printera is bringing automation not only to the construction printing process itself, but also to the design. So we do as much design algorithmically as possible. And what that really means is we can basically iterate on a design in seconds instead of having to go back and re-render items from scratch. And once we have a render, it converts into robot code, and that's what allows us to print. So I don't think the audio needs to carry through, but just demonstrating in real time this software that we've put together on the back of Rhino that you can see if a customer were interested in designing a planter, for example, we can change the pattern and the size in real time by just modifying a couple parameters. And that same code can apply to wall modules. The same code can apply to columns, you name it. It can be done procedurally and in real time. So that's kind of a fun element, especially as you're interacting with, potential clients, right? That can see, hey, I've got this idea. I like what you put forward, but I wish it was a little bit different in this particular way. And we can do that very quickly. When we look at designing for concrete printed structures or even non-structures, it's important to understand the capabilities of the printing system and its limitations. So, we often share this page with architects and landscape architects that they understand essentially what makes up a wall module. But in essence, you're printing out a hollow space and you're replicating CMU block to its greatest explanation, right? In other words, we're creating a permanent decorative form, not a structural element. The structural element actually comes from filling of cavities that we're creating over the course of the print. So in this example, you're seeing at the end of a given span of wall segment, you have a cavity, and that cavity has rebar dropped in, and then it gets backfilled with concrete. That's what's going through the structure. That's what the permitting boards and the townships and counties are looking at when they look to understand concrete 3D printing in construction applications. Now, the area between the void, you can go multiple different ways with it. You can fill it completely with concrete and live in a complete bunker, or you could fill it with insulation. You could fill it with all of your utilities and pass-throughs, So that's where that's where kind of the interesting nature of 3D printing comes into play. And even though the examples that you're seeing on the screen are showing straight walls, because that's what a lot of people understand in construction, what's cool to envision is that all of these elements can be done in any shape. So as we go through the deck, you'll see that we've done one wall segment that had a curve in elevation as well as in plan. So you can do some really interesting kind of features and bring a lot of creativity back to construction. This is just a zoomed in reference of the same thing that we're talking about with fill cells and passing through the electrical and HVAC. And then the other element is just the aesthetic value. So this is one area that we're setting ourselves apart from a lot of companies in the industry, especially those using the large gantry systems, is because we're using a robotic arm in a controlled environment, we have a lot of quality control. So over the course of a print, we're monitoring 17 different metrics in real time to be able to adjust, if conditions change even in the warehouse, or recognize any issues that might be occurring before they make their way into the ultimate print. So here you're seeing patterns as an example, right? Whether it's straight line, which is indicative of most concrete printing, or you can do things like weaves and loops and different elements like that. And where that really comes into play in construction is if you can imagine assembling a house where you have this pattern on the outside, you can now take stucco out of the equation of the house, right? If you spend a marginal amount of difference in the amount of material that it takes to create a little extrusion, to come out and create that pattern versus having a stucco team come over and completely cover the house with stucco. So there is a savings element here, but we still need to realize that in the broader scheme of the grander picture. Back to explaining how we work from a pre-printed standpoint. Again, this is part of that world's largest 3D printed project. We did all the columns for that job, and I like the way that this kind of came together to be able to show the timeline of progression. But basically, we produce in the warehouse, right? So you're seeing serial production of columns. They have to cure. Any concrete element needs to cure, whether it's precast or 3D printed. Our curing is a little bit accelerated. We tend to hit about a 3,000 PSI strength within 24 hours. And so for something like a column element, it could ship same week or early the following week. It gets delivered to site, and then at that point, it's in the contractor's hands. So we're a building material supplier. We're not general contractors and we're not installers. So we want to get integrated with as many of those folks as we can. But the great thing for them then is that the installation of these columns becomes very simple. They drop it over a rebar cage, backfill it with cement, and now you have a structural column, which you'll see in a future picture is now holding up the bond beam of this particular building.
Hey, Justin, for
Yep.
us I guess contractor or construction folks, what's the difference between a CBS, strength wise from just a regular CBS construction and what you're talking about? Because if I heard correctly, you're in the thousands for density. So I'm not exactly sure. But my understanding is that's a significant difference.
Yep, absolutely. So CMU block, that's our building material of choice in Florida. It tends to come in somewhere between 2,000 and 2,500 PSI compressive strength. So very key is its compressive strength. Whereas the concrete that we're using that's designed specifically for 3D printing comes in anywhere from 5 to 7,000, depending on how much accelerant we hit it with. So you are talking at least a 2-time strength, 2 times over in strength from what a block would be. And then again, the structure of your house comes from filling those cells. So when engineers are looking at it, they care more about the fill cell, right? And what you're dumping into that, making sure you've got the right rebar gauge and everything in there. But it's still nice to know that the overall structure of the house, right, that all the aesthetic elements and what are making up your walls is stronger. And talking about how it compares to block, the concrete that we're using is actually very dense. So there's no large aggregates in it. The largest aggregate in the mix is the sand particles themselves. I've seen some mixes with up to 3 millimeter sand particles, but that's about the largest you'll ever see. And so you can imagine if you took a piece of this concrete and broke it and looked at a cross section, you'll see a very compacted, very dense piece of concrete. And that's also very good for resisting water permeation. So if you're still doing construction with traditional rebar modules, for example, with that thicker, more dense concrete, you're giving it some more longevity because water shouldn't be impregnating the concrete. Just to illustrate very quickly kind of what an overall construction project looks like for us. Um, as we mentioned, especially as it pertains to tiny homes, as we mentioned, we print the wall module in our facility, which is what you're seeing here. So we do them in panels up to 8 feet long, and then we can go up to 10 feet tall because that's the limitation for transportation. We generally like to go a little smaller, and then those modules get brought to the construction site where there's already a cured slab with exposed rebar ready to receive the modules. So think of a general contractor, instead of ordering up 6,000 blocks to make a house, they'll order up like 15 wall modules, and a telehandler will drop them into place, and the whole thing will go together in about a day for something as small as a tiny home footprint. And then here you're seeing that the cells get filled and the hollow spaces. And then what we also are often asked, and you'll see its inclusion in this video, is, well, what if you don't like the look of the 3D print layer lines? And you want something more traditional, particularly on the inside of the house, right, where people are used to having drywall. It works just like block. You'll see that fairing strips go in, which is what you're seeing now. And then with the fairing strips, you could run utilities on the surface instead of through the cavities. That gives you another element of flexibility. Your insulation, and then you finish it off with drywall. And if you didn't know any better and you were standing inside a house that was finished that way, you wouldn't know it's 3D printed. So you've got a lot of flexibility on either end, right? You can go extreme 3D printing and save some money and just have different layer lines exposed on the inside of the structure, or you can go crazy and stucco the outside and drywall on the inside. So it really gives you a lot of flexibility.
That design, Justin, is about 750 or 800 square feet.
Yeah, so that design is actually for a tiny home printing company in Minneapolis. So that is their design. They designed it 850 square feet, I believe that model is. And you may be right, it might be 750. I got to take a look at their inventory. But yes, that essentially is what that is. It's 2 bedrooms. And you can find a lot more information about that.
Great.
Another element that Ray touched on that we think is important, right, is what's our environmental impact as we use this material. Concrete gets a very bad rap internationally, just because it is the world's, I think it's the most or second most used construction material. And I think it only falls in the second place when people consider water as the first. So what you end up with is, a lot of negative press on how this impacts the environment. But the reality is, when you look at it on an individual basis as a material versus any other material, it's not that far off, right? Of something like wood frame, or if you want to use any other method, right? Outside of like pumping clay and raw earth. But nevertheless, we say, how can we lower the carbon impact and just the general environmental footprint? And so the first point is just the nature of this being an additive construction method means that we're only putting in what needs to be put in to produce a particular module, right? So if you want an 8-foot wall, it's taking exactly what an 8-foot wall of cement will take to create that object. And when you expand that out over an entire print day, the waste efficient is about 1 5-gallon bucket from Home Depot, right, worth of concrete waste. And that's just the material that we use setting up the machine and getting the consistency right and flushing the hose out at the end of the day. Otherwise, everything that's coming out of that nozzle is going into an end product for an end customer. Now, Ray alluded to this a little earlier, and this is something that we're very excited about, but we piloted an additive with Carbon Limit. So Carbon Limit's another South Florida startup, and they came up with an additive that it goes into the Portland cement, into the mix, and it turns the concrete into a CO2 absorbing concrete, right? So it's like it acts as a sponge, and it sucks up CO2 out of the atmosphere, and it permanently sequesters it into the concrete. And more so than just that feel good factor, it actually gives it self-healing properties like Roman concrete, because the CO2 that moves in, it hits that additive, and the additive calcifies. And so now you've got like a calcium rich concrete. And if you have micro cracks, next time it rains, those cracks fill up with that calcium, and it gives it that self-healing property. So we piloted this with Carbon Limit into a wall module, and they went back and they did some lab measurements and everything after, I think 30 days was after 180 days. And we see that the capturecrete absorbs, substantially more carbon than the control. It also gave us higher strength numbers. So it's kind of an interesting thing. It's all working towards becoming carbon neutral or even potentially positive, or sorry, carbon negative for the structure. And when you factor that in with other environmentally friendly elements, right, like good insulation or good windows, you could end up with a really good structure that has a very minimal environmental footprint. Um, and then, as we mentioned, it not being subtractive is important because anybody who's built a CMU house knows this pile of rubble, right? And even this one's kind of small, but every time they knock something out or need to cut a block, right, they're taking away from an existing, an existing method, right? There's subtracting. So we're additive manufacturing as opposed to subtractive. I mentioned the curved wall, so it's kind of hard without seeing the bottom of it, but this wall actually has a curve in plane as well as in plan. So that gives you an idea that you can do some really fun things with house design. Same thing with the image on the bottom left. We're actually implementing that the weave pattern to a wall module only on half of the module. So you see the level of control. And outside of the pictures, the point of this slide though is to talk economics, right? When we talk about why is 3D printing an economical choice, the reality is today it's still on the journey of becoming the most economical option, but it's not presently. But it has a couple things going for it. So the first is that curves don't cost more, right? The robot doesn't care if it's printing a straight line or if you're doing a fun curved house or perfectly circular house. In traditional methods, if you want a curved block, you're paying specialized labor at a significantly higher rate. So that's somewhere that even today 3D printing will blow the competition out of the water. And you also end up with a stronger structure, right? So in Florida, as an example, you want resiliency against hurricanes, you want resiliency against termites. To some degree, you want resiliency against vandalism, particularly if you're dealing in rental properties. So there's a cash savings over the lifespan of the product that's not immediately realized up front, but there are other elements that you put in, and we have yet to find an insurance adjuster who doesn't love concrete printing, because even if you want a house with straight walls, you can add a curve to the end, right? Because we can't print a hard corner. Typically, we have about an inch or two of radius, and what we tend to do is we exaggerate that. Now give the house a foot radius. And from the inside, it feels like a bigger space because you don't have a corner casting a shadow. And from the outside, the wind just moves around it. It takes on a really nice aerodynamic property. And then everyone's always asking, well, how much is it today, right? And so what we typically say is it's about $500 a linear foot for a 10-foot wall. And that can move up and down. We think that in the next couple of years, there's a track to being able to reduce this by another 40 or 50%. And that would probably be the final number with volume. But right now we represent such small volumes to the concrete manufacturers that, the reality is that we're about $500 a linear foot. Now, for high-end construction where you're going to stucco it over anyway and put fairing strips and all that stuff on the inside and drywall, it's not the economical solution. But if you can cut those other elements out, right, now you don't have drywall at all, you don't have stucco at all, and you can already do the electrical pass-throughs and utilities in the concrete module, then you're also saving people time on site. Now you're into the range of saying, hey, this is a really economical option. So
One thing, Justin, I would comment on there, and this is more for the investors that are either here or going to listen when we post this on YouTube. But what we're talking about when we talk about these smaller footprint homes, we're not talking about low income. I mean, it doesn't necessarily have to be low income. We're just talking about being able to take something that is really nice, just reducing the size of it. And because the reality is, if you're a couple and you're downsizing from your whatever family you had to now it's just you and your spouse, you don't need 3,000 square feet, but you still want to live nice. You still want design elements in your home. You still want to have the protection and the resiliency, etc. So I think that's what we're looking at. I'm not necessarily, although this could be a good project for just cutting costs to the bare bones. It's more about taking something that is nice, maybe not the cheapest, but it's nice, but the cost is lower just because of the size of it.
Yep. And a perfect example, that's one of the first projects that we were asked to participate in. The development company wanted to produce a series of tiny homes with RV pads, right? So that the idea would be it's an RV park and people can bring down their large very expensive RVs and have a nice kind of outbuilding that is parked next to, and they can spend some time living in an outbuilding next to the RV. And then when they leave for the season, they know that they've got a resilient structure right here in Florida. It's they don't have to worry about when the hurricane comes through that's going to take any damage. That project ultimately, the developer of that project ultimately thought we were going to pay for the whole thing, so that fell through. But it was still a really good use case in being able to put forward designs and concepts and kind of walk through all the intricacies of a project like that. And we think it had some real potential. Um, then just kind of going into other elements. Actually, that bottom right corner is exactly that project. So that's funny. I didn't realize I had that in the deck, but that would have been that exact house that we were talking about for that RV with the little golf cart port. Um, but yeah, so I mean, architecture, hardscape, civil, right? You can do all different types of things optimized for 3D. Anything you find in a high footprint or a high foot traffic commercial environment, concrete's a great material for that just because of how robust it is. So, you look at park benches, you look at, high-end planters and landscape elements. We've seen a couple companies implement these stairs as kind of an interesting element. So yeah, this is just examples of things you can do. Um, as far as our facility, I just wanted to give a little window into how we do things. So you see our robot in the back there. It's a relatively humble facility with one robot. And the point there being that we keep our overhead very low, right? It's another element of being able to achieve good cost comparisons is that to run the entire facility, it really takes only 2 production workers. Um, we have run it with an individual production worker. It is definitely possible, but we keep 2 just for the safety purposes, right? When you're working with a robot, it's good to have somebody else in there, especially with heavy concrete. But there's often times where one worker is running the production and someone else is handling emails and things or packaging stuff. So it becomes a very lean manufacturing operation. And then on the left, you can see how the wall modules are transported by truck to the site for ultimate installation. So a lot of cool kind of things happening there. We started talking about the Clay Street house up in Tallahassee. So that was the first 3D printed home in Florida. That was done by Printed Farms and Centerform, and Centerforming was the company that I acquired. So I wasn't on site directly for this. My business partner, Justin, was. But I know all about it, right? It was 1,580 square feet. And again, this project was done with a large gantry printer that was erected on site. And this is where the idea of pre-printing was born, because this kind of middle image of where you see that the house kind of comes out past the front door, that did not fit within the footprint of the printer. So they actually printed those wall modules in the master bedroom. And then after the print was complete, they moved them back out into place so that they could fit everything within the footprint of the printer. And in addition to that, it was 32 print hours, but they've had a couple days where they were printing and all of a sudden it started to rain and they only got 30 minutes of printing in and you have to shut everything down. So we were looking at, what are the challenges that you have when printing on site, and is there a better way? And we have the better way. A couple other projects just highlighting kind of landscape or architectural features. So, this house was kind of interesting because it actually had wood 4x4s holding up this front overhang. So we were able to slide those out, drop them onto the inside of a 3D printed column to give it some aesthetic value, and then slide it back in and reattach. And so that gives you an idea of, hey, you could add this additional aesthetic element to a property. And then we kind of, put the cherry on the cake with adding some planters in the same pattern that match and really complement. So you feel like it was very intentional and purposely built. This is the largest 3D print structure globally. It's the Dixon Stables in Wellington, Florida. I mentioned it's nice to see a finalized picture of it with all of our nice columns holding up the building. And you see some action shots of how it came to be. But the fun fact about that, and again, something that sets us apart, is just the print quality, right? So, using a robotic printer with finer layers, we're able to achieve a finish detail that is good as a product on its own. The finish patterns and things that I was showing you in previous slides, a lot of companies can't put out that type of quality, right? So if you look at a traditional house and that's 3D printed, I should really include an image of one. You'll see that there's, every fifth layer is kind of gloopy and over extruded. It just doesn't give you a very pleasing aesthetic. But we have extreme layer consistency and quality to the point that this house, or it's actually a stable that was produced, the whole thing was 3D printed. and they ultimately covered everything with stucco except our columns. Our columns just got a coat of paint. And if you were to visit the stable now, it would be the only nod that this thing was actually 3D printed. So it's kind of a cool feather in our cap and something we like to talk about. This is the house that curve module that I showed you earlier is going towards. So again, this is back to, the idea that you can do a lot of really interesting architectural things with 3D printing. This whole house was made to resemble the Fibonacci curve. And, it's kind of a neat house, 1 bedroom, large 1,400 square foot, large bedroom, 1 bedroom. And here's how all the modules would go together to assemble that structure. I mentioned at the beginning of the presentation the deployment of Florida's first artificial reef, 3D printed artificial reef. These are some action shots. It was specifically designed as an archway so that turtles that have buoyancy issues from boat propeller strikes can get up under that and rest and hold themselves under. And another thing we were super happy to see was only 2 hours after it was submerged, the turtles were already on it and they figured it out. And the Oceanographic Society, who was the recipient of this reef, were so ecstatic about it that they actually came back and ordered a couple more modules like the very next month. So a very exciting story for us there. And then this is the next Florida project that we have on the works. So we're calling it Print Deco because it's in similar style to Art Deco with a lot of curves and a round window, for example. The family that commissioned this, they've since redesigned it to be a single story instead of multi-story. But that project is hopefully slated to commence before the end of this year. And then we also very recently just got integrated into the national park system, where Big Cypress has asked us to come up with some models for small 400 to 600 square foot tiny homes that could be used for their park rangers. Because a lot of the employees there commute over an hour and a half each way to get to Big Cypress into the areas where the government employees are working. So they came up with the idea of saying, hey, let's put 8 to 10 tiny homes in our campsite, and they could use them for the park employees and then rent them in the off season. So these are some concepts that we put forward for them. And outside of these exact concepts, we now have reiterated on it a little further, and we're hoping to win that business in the next couple of months. And then we're nearing the end, but I just wanted to call to your attention some other interesting applications. So things like privacy screens, they could be hiding trash receptacles or dumpsters, and they could be hiding pool equipment or your generator. There's a lot of kind of interesting elements that you can do where air still passes through, but you have something that's aesthetically pleasing. And then in these images, you can see the extrusion of logos or different types of design elements, right? Even if you're not oscillating the nozzle to create the pattern, you can actually build the pattern into the object itself and come up with something that's really artsy and unique. Other features, we mentioned the stairwell, lots of benches, retaining walls are a big market. Thinking golf courses and fairways and things, they really like this. And then we've done commercial signage. This sign actually went out to Texas from our facility. And this thing for scale is about 35 feet long from the end of the A to the beginning of the C. So it's quite a large print. And a couple images that don't belong to us, but I wanted to include them because it's a great accomplishment by the company that did this, called Brill. They took an existing multi-story residential unit, and they added this concrete 3D printed facade to take it from just a regular rectangle to something with kind of flowing geometries. And it's a really cool application of how this can be used in more of a city or urban environment than just typical single family homes. Architectural columns, large planters, things like that. So and then I conclude this by mentioning that we are actually about to undergo our first Reg CF fundraising campaign. So this will be the first time that we're taking on real capital outside of raising a safe note ourselves. And so I threw a QR code. If anybody's interested, that platform is going to be launching with us in a couple months. So I threw the QR in just to say, hey, if you're interested in receiving email updates about that and potentially becoming an owner or part owner in Printera, we welcome your interest. And yeah, there's a couple perks for people that are early to the game on that. So definitely take a look and let me know. But I feel like I've talked everyone's ear off. So at this point, I mean, Ray, I'm happy to take questions, or if you have any particular questions that you want to spur a conversation with, I'll leave this up in the background in case anyone didn't get a chance to scan it. But yeah, go ahead.
Yeah, no, for sure. I had somebody text me while we were talking. They couldn't get on the call, but they did have some questions. This guy is actually a builder, and he does, I guess, something similar. He does. How would I describe it? It's not the wheeled tiny homes. It's the ones that are like containerized that you can kind of take to a site.
Okay, like
Um,
shipping container homes.
Shipping container homes, right? So they kind of same sort of scenario where it gets built somewhere else and it gets rolled over. But I think to your point, and I guess his question is, these get to be very rectangular because essentially they're modular in
Yep.
nature, and nothing against modular homes. But if I were to do something like this, I'd want to create some sort of aesthetic aspects to it. And so my question, and where he was coming from as well with his, how to integrate the two. What do you see as a potential there for being able to add on to what they're doing, and maybe making it stronger, better, etc.?
Yeah, so we've actually already had a couple discussions with some shipping container home producers. You already really touched on one of the elements, right? And it's the shipping container homes are a little bit more restricted in terms of how unique they can be with their overall footprint. So where we were integrating, for example, was this company wanted to stack two shipping containers, but they didn't want to stack them right on top of each other. They wanted to do like an offset, like an L. And so they needed pillars to hold up the second half of the house, and then underneath that overhang to create a walled-in space. So there absolutely can be a marriage of two different types of products, especially in shipping containers. And if you were to talk to me 3 or 4 months from now, one of the greatest nods to that concept is actually the city of Hollandale Beach in north of Miami. They are working with us now on a new EV bus station. So they've commissioned this through an architect, and that the winning bid was a project that was predominantly shipping containers making up the bus station with added elements and accents in concrete 3D printing. So together we're going to be deploying that. And that'll be a real world use case that I think will be the first thing that you'll be able to see with that, because ground is already broken on that project.
Fantastic. I mean, I think that's the advantage, because there are other people that are doing similar things, but it's not the same. It really isn't. Yes, everyone builds to a Florida code, but I want to exceed the code. I want folks that really value security and value the resiliency and can pay a little bit more to have that as an option. And I think that there's some credible options there. I'm going to hold off. I'm going to see if I can pull up the other question that he had. Second here. If anybody else has a question.
Yeah, or has anything to add? I mean, there's definitely love taking questions. I see one in the chat. What sizes will you guys offer? In terms of sizes of tiny home, so again, so we're not fabricating an entire home, so we'll do whatever the general contractor wants. When we talk about tiny homes specifically, there's limitations in Florida at the county level around what the minimum square footage is that you can have. At the moment, like Port Charlotte and Punta Gorda are the kind of the areas where they're accepting of square footage is less than 1,000. Same thing for Fort Pierce. We're working on a pilot project. But yeah, ultimately, like if you had an architect or a plan that you liked, we can adapt it for 3D printing. So, we can do any size project. It just becomes a matter of how many wall modules you put in place to be able to do a house as small as you want, right? Kids playhouse, all the way up to, something big that you might see on the intercoastal or ocean.
The question that I had was that I saw was related to that, the square footage of the land, the lot itself, right? How big the lots have to be. This sort of question. I think that's the hard part. I mean, when we talk about challenges, it's not even the technology at this point to be able to put something together. But when I'm looking at cost and I'm looking at a piece of land, if I'm going to be using, just a quarter of the entire lot to the actual construction, and I can't do anything else with the rest of that, it's kind of wasted space. And it kind of goes against the whole, argument and the whole piece about the demand, right? The demand is high. We need to be a little bit more dense as it relates to construction, not less dense. And so I think that's going to be key, talking to folks. one thing I did hear, and I don't know if anybody on the call or you, Justin, can confirm. I heard that essentially when you're dealing with some of the economic development folks from the counties and the folks that are dealing with zoning and zoning permissions, et cetera, that the word, when you talk about tiny homes, they don't like it. They don't like to be, to use that term because there's some sort of stigma with it, which is completely different from when I talk to investors. I talk about tiny homes. They're like, tell me more, right? They want that, but somehow there's this distinction between who you're talking to, and how you define these things. What is the stigma with, at least at the development side, from working with the cities and the counties as it relates to tiny homes? Do you know?
So I can only speak to the experience that I have with Fort Pierce, because we're trying to interact with them for this pilot project. They're looking at contributing a lot for us to do a first house. They actually didn't have a hard stigma against it. The building official there was like, I grew up in a tiny home. We didn't call them tiny homes at the time, but back in the day, before everybody wanted a mansion, right? It was pretty typical that you'd be in something 1,000 square foot or 700 square foot, especially in Florida. So they liked the concept that we're putting forward, and outside of the outside of kind of the higher end market, the other market that we're looking at serving with these smaller footprint houses is your first time home buyer, right? Maybe somebody who recently graduated or is a trade apprenticeship or something, and they want to be able to put their equity into something that's not rental, right? So that they're building a little bit of a nest egg. And these smaller structures really hit an attractive price point because they offer all the elements that you need, before you have a big family, right? And then you're building equity in something. So that's where the counties were excited. And with regard to code, right? So when we met with the building department there, they were talking about changing setback requirements and things because they were open and receptive to the idea of trying this. I think it's just one of those things that local government needs to kind of catch up with, just like the technology itself, right? Whenever we submit permitting, we never specify, oh yeah, 3D printed, right? It's not in the title, right? They want to see it's a post and beam system because that's what they're familiar with. So, we like to answer all the questions and try and curve any concerns that anybody in government might have. But it is funny, right? It comes down to a lot of how you market it and how you talk about it.
Yeah,
Yeah.
and I wonder if it has to do with the definition of a tiny home. Like like as I started today, right? With Florida has an actual definition, and it's 400 square feet or less, not including a loft. And so maybe using that word tiny home automatically kind of in their minds, just being very linear in how they define things. Maybe that's why. Whereas if you just said, hey, we're looking at smaller footprint homes, whether 30, 40 years ago, 1,000 square foot home was a nice size home. I mean, that's what all of a sudden we went into these, 1,500, 2,000, and now, depending on who you talk to, that's too small. But that's what I'm focused on. I'm not necessarily looking at tiny homes or ADUs. I'm looking at sub 1,000 square foot, smaller footprint homes that I think will hit a majority of these folks that we're looking at. You mentioned millennials, and I talked a lot about the aging population. These are the folks that are looking for these type of structures. They don't need a lot of time. They don't want a big yard. They don't want a lot of extra cost for empty rooms that air is blowing in that have nothing to do with them being cool, right? So I think all of those things, when you add all those up, it does reduce the cost, because that's the other thing about larger homes. You have to maintain that under air and all that wasted air that's being used in there, and then there's more things that can break with it, right? So I think that may be it. And there's some builders out there and some folks that are dealing with counties. I'd love to have a chat with you guys about how we can partner with Justin and his team about doing some of this stuff. I mean, that's my ultimate goal here, is to be able to bring this to passive investors as an opportunity, and also for those folks that need these type of homes. We talk all day long about people can't afford 500,000 square or $500,000 homes. Well, if you can't afford that, we'd love to be able to offer you something like this, where you're in the 200, mid 200, maybe at the most 300,000, depending on what you do. That's what we're looking for, and being able to fit that niche that is there in between those that can afford the larger stuff and those that must rent because they can't, and we want to fill that need.
Yeah, absolutely. It's funny how you want to start your life in something manageable and affordable, and then you also want to, as you get into your later years, right, have something manageable and affordable. So it feels like it's a good investment up front. And then what one additional market that I want to hit on that if anyone's looking at it from an investment standpoint, they make really good short-term rentals as well, right? If you're in the Airbnb market or vacation homes, right? It's nice to have something that is unique that people are going to want to stay in, but it also has that resiliency factor, right? If you have interior walls that are concrete, you're not patching drywall and you're doing all that level of maintenance that comes with having that high turnover property. So I think that's kind of a cool element.
Yeah,
Um,
absolutely. I
yeah.
think we have some questions. Let's see what we had. Do we hit them all? Somebody's asking me, okay, the sizes, you answered that. A question about what areas I'm pondering. I really like Central Florida for a lot of this. There's still a lot of good land available. Justin talked about how it's so dense in certain areas of South Florida. There's just no place to build unless you stack. All right, so but when you start going north and you hit uh, certainly Treasure Coast and further north, Fort Pierce to Justin's potential project that I'd love to, maybe do something there, and even further north, that opens up your corridor going west. And then, of course, if you're on the southwest coast of Florida, then you've got all kinds of room. Starting with Fort Myers, even a little bit south of that, going all the way up to Port Charlotte and north. So there's those areas in what I call Greater Central Florida, where there's a lot of potential, and a lot of folks are looking for more affordable housing. They don't necessarily need to be in South Florida. They want to be in Florida, but they can move around. A lot of people that are coming from New York and other places, they're not all moving into South Florida. They're looking for a little bit more economic. They want to be able to buy something cash. In many cases, just want to buy. They're downsizing. They want to buy cash, not have to worry about a mortgage, but they want resiliency. So those are the areas that I'm focused on. I'd even look as far going north of Orlando, going up the I-75 corridor towards Ocala and Gainesville. There's some really good routes there. So I like to stay close to major lines of communication because most people want to live around. Maybe they don't want to live in a highly dense area, but they want to live close. So they want their mixed use, or they want to be able to be near a Walmart, near some sort of entertainment. So that's kind of where I would focus any kind of projects where I can match with a developer that would be willing to do those.
I see some more questions starting to come in too, right? I'll address Alfredo's question. Alfredo, so you mentioned you just missed the beginning of the presentation. What makes the panels? So we are talking about concrete 3D printing. So when we talk about the housing panels, right, each wall module that we typically do up to 8 feet long, up to 10 feet tall. And all of those modules are 3D printed concrete. So you get a lot of longevity and strength. But also 3D printing gives you customization elements, right? So whether it's the pattern like you see behind me, or if it's something even in terms of the shape, right? You could do sweeping curves or just different elements that are just way out there. We just designed a triangular house, for example. So you can do some cool stuff.
I think the next question is from Bill. What will they cost per square feet? I know you touched a little bit on the panels themselves. Any sense of what maybe in your work with some of the ones that you've done, when you talk about a price per square foot, have you been able to kind of measure that a little bit?
So yeah, I mean, it comes down to what we're hearing back from general contractors, because again, we're the building material supplier, right? So our hope is that as existing GCs want to go and build, they order a 3D printed wall panel instead of a bunch of block. So we touched on our wall panel price at a Um, at a 10-foot wall, you're looking at about $500 a linear foot. So I guess if you broke it down, it's like $50 a square foot. But again, what you're picking up is you don't have to stucco it, you don't have to do interior drywall, you don't have to, your tradespeople don't have to spend the same kind of time running utilities and electrical because we're gonna send the modules with all those cutouts already made. Um, and then as far as that fits into the overall footprint of the house, right? The overall cost makeup. Um, just working with another tiny home developer, we're hearing that something in like the 400 square foot range is going to be like 160K. So it, I don't know how he arrived at his price point, but that's just the one example that I know of off the top of my head.
So there's a question from James about whether we're selling homes or renting them. Obviously, that's a discussion that I would have with someone that Justin and I would partner with potentially about what that would look like. But ideally, I'd like to do a proof of concept to really kind of kind of hone in on some of these things, sort of generate that interest from folks. They love to see, investors love to be able to see things. And like myself, I like to be able to participate in things that are good for the environment. I mean, who doesn't, right? I mean, it's like a win-win. So initially, a proof of concept to do maybe one or two to sell. We demonstrate it, we market it, we do all of that to have sort of these models. And the idea then is to then take that, buy a larger piece of land or partner with somebody who owns a larger piece of land, and then develop a small footprint or a small square foot community that has some sort of central, entertainment areas, almost. And this is where the multifamily comes in, because essentially I could see where you'd have a development of homes, of these smaller homes with some sort of central community that people can tie into, whether there's a pool, a clubhouse, etc. And then some of those can be sold, but then we would take that from speaking like an investor, we would take some of those that are sold and take the money from the profit that we would make for those, and then use that to fund those general those amenities, and also some of the ones that we won't sell that we would rent. So you'd have a community of both renting and owned properties inside this community. So that's kind of a concept, and obviously developers do this all day long, and I'd love to be able to have a discussion about that. But that's, to my mind, how it would work really well, because you investors are going to invest for long term in many cases. This quick twitch fix and flip stuff is okay. The idea is you invest in something and you grow your wealth. So that means you have to hold on to something, and that's how you do it. You sell some, and then you use the money for that and keep some and rent those. And I think that would be a good way to do it, while still helping others living in these smaller footprint homes.
I see Mo was asking whether we're building in developments only or single family lots. So again, from my Ray will probably have a different answer to the question because he's from a different background. From my take, right, as a material supplier, we'll participate with general contractors that want to do anything. A popular segment that we're seeing for single family lots is ADUs, right? Additional dwelling units. So people already have a house, but they want to create an outbuilding, and they could either turn it around and rent it, or it's an in-law suite or something like that. That's a popular element. What you see most of the time in terms of code requirement, though, is that most counties in Florida require 1,000 square foot minimum. So now you're not into the tiny so much anymore, unless it's an ADU. But then the rule of the ADU is it has to be approximately 50% the size of the primary dwelling, right? Or smaller. So it assumes that you already have, some substantial house on the lot with room to do something 50% or smaller in footprint. And then to the first part of your question, what kind of partnerships? That's yeah, I hand that one back off to Ray in terms of what he's looking for. What I will say from Printera's standpoint is we just want to get in front of as many general contractors and people as we can to, first of all, educate about the solution, right? As I mentioned, whether it's us or not, we think that more people that see 3D printed homes, it helps the industry in general. but also have general contractors that are willing to try something different, right? We found in the 3 years that I've been in business now, the reason we don't have more houses, right? We have a lot more landscape and architectural features is they're easier to get past, right? General contractors are more willing to try something on a big architectural element than a whole house. And I think at present there's about 50 3D printed homes in the country that have a family living in them. And there's something like another 300 or 400 3D printed homes currently in construction. And those are with those kind of big companies that are printing on site still. So if you go to YouTube or Google and just search 3D printed houses, you'll see a lot of walkthrough tours. So while we're very, very early to the game still, it's also we're at a nice time right now where it's not untried, right? There's enough people living in them around the country that it's a substantiated building technique and concept. And the last element I'll say on that, which would have been probably good during the presentation, is that Fannie Mae actually just introduced language this year that specifies a 3D printed home is no longer considered an exotic building method, which previously would have excluded it for application for Fannie Mae. So now Fannie Mae looks at 3D printing and it's applicable for people to get Fannie Mae financing for their house.
That's fantastic. I'll answer the question on the partnership as an idea, because obviously every partnership is different, and the more I'm in the space, the more different ways to structure partnerships. In fact, I just gave recently a course, if you will, not a course, but more of a webinar on how LLCs play a role in real estate and how many you can do it, Sears LLCs, all kind of things. But I would say that an easy way to discuss it right now is, and one of the things we've already started doing is looking for people that actually have some land that either they're trying to sell, or maybe they'd like to partner with us on this. And instead of selling the land, we partner on this. They own the land. That takes away some of the holding costs for the investors, because investors are always worried about money sitting, right? So somebody's got a piece of land. We bring some additional capital to bear, and when that property is built, then it gets sold, and then that partner who owned the land would obviously get paid for the land, and we'd have to negotiate a price for that, what that means at the sale, and then and maybe additional split for just being part of the partnership, for being part of that, because obviously they held the land. Now they already had the land; they're already holding it. So it's not a tremendously increased cost for them, but there is some cost. So, and we'd love to have those discussions in areas where it makes sense. And yeah, I mean, you guys, my information is there. My QR code there will get you to all of my contact information. And I'm looking to work with Justin on some of this stuff, because I want something that people, that investors can be proud of, but also that brings them some return on investment, and not necessarily low income housing. That's a possibility. I'm not saying we're not doing any of that, but for me, it's about smaller footprint, lower cost homes that people love. And that's what I'm looking for. All right. Did we get everything else? Do you have any lots under contract for a development? I don't have any lots right now. Again, part of the partnership that I'm looking at is somebody that owns some lots. Although I will say I started looking for acquisition of some lots. I'm not a land guy. I always, a lot of times, when I invest, I like to be able to get some cash flow going fairly quick, cash on cash. And when you do development, obviously you're sitting for a while before there's any kind of return on that. But I'm so excited about this project. I'm actually starting to look. My wife's an agent, and I've had her looking for some potential land as well to do maybe a one-off. I had one of my children is 23. I may buy one for him. I mean, honestly, this is the kind of stuff, to your point, Justin, earlier, millennials should be all over this. And I don't buy this, I hear this all the time, and I read it, and it bugs me. Like, millennials don't want to own. That's no longer what millennials do. Millennials don't want to own because they can't afford it. Give them something they can afford, and they'll want to own it. Who wants to live, who wants to rent? I mean, when we can buy, and that's a generality, but I would say that there's a lot more interest than people are given credit for. They just, when they don't have an option, their mind turns off completely and it's not an option for them. So they don't think about it as something that's attractive to them. But I got to say, I know a lot of millennials that would love to be able to buy and they can't. So they rent. Mo, I see your questions there. Let's chat. I'm honestly, this is pretty early on for me on this. I was hoping that part of this chat is to bring, to attract some folks that are general contractors, that are developers, so we can have these discussions. And obviously, my team would come in, obviously underwrite, and then we'd have to present this to investors so that it's attractive to them. So it depends kind of answer to a lot of these, because you just don't know until you start looking at it. That's why the proof of concept is something that I'm really interested in, because even though it's a one-off, if we can make it work on one size lot, those costs, when you scale them, should go down, and that should make it even more attractive as you're building more. So that's the idea. But I want to measure exactly what it is to do one, take out what the land cost is, and take out some of those extraneous things that you know what those are, what those costs are, and then just worry about the actual vertical construction and what that looks like. Justin, one thing we didn't talk about is on that carbon footprint. I know we'd had some conversations that even the slab can be built using that mixture, so that also then absorbs more, I guess, CO2 from the environment, which is even more attractive, even though that's not something that you personally would do. But that mixture, I think, is critical, because the more we're able to take out from the environment, I think the better the way this is going to be looked at by folks that are really interested in improving our environment.
Yep. And that material that'll actually sequester its full capacity of carbon within the first 30 to 60 days. So, in a slab application, that's a pretty good use case. Slabs, I've even heard that the fill cells, could be used. But again, that's not an exclusive technology to us, right? That's another South Florida startup. So I encourage anybody that's interested in that too, to look up the carbon limit, because they're doing some pretty cool stuff with that. Primarily in government, like Department of Transportation use cases, but I know the more widespread we get that, the more impact it has, right? So we're just the first ones to implement it in 3D printing. So we were excited about that, because the 3D printing mix is very particular, right? So like a little bit too much Portland cement, or a little bit too much water, and the whole thing just doesn't perform the way that you want to. So when they said, "Oh yeah, let's throw this stuff in there and see if we can suck up some carbon," right? We were all nervous. Is it going to affect the mix too much to print? At the end of the day, it didn't. So yeah, it was pretty cool.
All right, I see we hit the end of the questions. So at this point, unless there's anybody else, any questions, happy to chat offline. As far as what my company does and how much money we have, I know there's somebody here that thought, I guess they were, I don't know why they're aggravated. They're saying I don't have any money. Well, I got to tell you, I have a real estate fund. We have over multi-million-dollar in properties that we've acquired. Am I rich? That's not what I'm advocating here. Do I have money to go and invest in one of these? Of course. And I want to be able to bring this opportunity to more people through the fund. But there's always going to be some haters out there. I'm not exactly sure why, but I want to deal with people that are positive, that are looking, that see the benefits here, not just for themselves as an investor, but also what that investment will do for the general community and the environment. So those two things are what makes this a win-win scenario. So I think that's all we've got. I see Alfredo says, thank you, Justin, good product. And some other things there. So I think that's all we've got, Justin, unless you want to have the last word here.
Yeah, no, I'll just say that, to anybody that was listening, or anybody that finds this later and listens in, whether from a future purchase standpoint or otherwise, I'm more than happy to talk about concrete printing. So reach out to me. If you go to Printera's website and you submit a form, it'll find its way to me. Otherwise, it's just jdangelo at printera3d.com. Feel free to shoot me an email. I love to talk to anybody about this stuff. It's, again, I want to educate as much as I can. So thanks for taking the time to listen in. And Ray, thanks again for putting it together and having me in, because I think it was cool to get out there.
My pleasure. And I look forward to chatting with anybody about how we can partner on these. So thanks, Justin, for your time. We'll get this posted out on YouTube and go from there, my man.
That's good. Have a good night, everybody.